Now let's start today's topics. Okay. Now let us start. The first example, the approximate value of log of 99 to the base e. What is that approximate value? We have given that log of 10 to the base e is equals to 2.3026. This is the value. Then what is the log of 99 to the base e? These are the options. That is a 4.05952, 4.0952, 4.5952, 4.4952. Now we'll solve this example. Now the given function is logarithmic function. Therefore here f of x is equals to log of x. Here the 99, it is close to 100. Therefore here we take a is equals to 100 and h is equals to minus 1. Because we want to find out the value of log of 99 and hence a is equals to 100, h is equals to minus 1. Okay. Now what is the formula for the approximation? F of a plus h is approximately equal to f of a plus h into f dash of a. Okay. Therefore f of 99 is approximately equal to f of 100 minus, substitute the value of h is minus 1, and that's why here is a minus 1 into f dash of 100. Okay, the given function is f of x is equals to log of x. Then what is the derivative of log of x? Is 1 upon x. Therefore f dash of x is equals to 1 upon x, and we'll find out the value of f of 100 first of all. That is f of 100 is equals to log of 100, and it can be written as, that is a 10 log of 10 raised to 2. And using the rules of the logarithmic, that is a log of m raised to n is equals to n into log of m, and therefore here is a 2 log of 10. We know the value of log of 10 which is given in the example, and that is a 2.3026, and here after multiplication we have f of 100 is equals to 4.6052. Okay, therefore f dash of 100, also f dash of x is equals to 1 upon x, and that's why f dash of 100 is equals to 1 upon 100. Now we'll substitute the values here. Therefore f of 99 is approximately equal to f of 100 minus f dash of 100. Substitute the values, then you will get, that is a 4.6052 minus 0.01, and after subtraction you will get 4.5952, and hence the option C is the correct one. Okay. Now next example. The approximate surface area of a sphere of the radius 3.02 centimeter is approximate surface area of the sphere. For this, the first option is a is a 36 centimeter square, B is 36.48 pi centimeter square, C is 30 pi centimeter square, and D is 40 centimeter square. Okay. Now we will find out the first. We know the formula for the surface area of the sphere. That is, surface area of the sphere is a 4 pi r square, and here we are taking the variable as x. Therefore f of x is equals to, means what's the surface area? F of x is equals to 4 pi x square, where x is the radius of the sphere. Then it's a derivative. F dash of x is equals to 8 pi x, derivative of x square is a 2x, 2 into 4, then we have here 8 pi x. Here we will take the value of a is equals to 3, and the value of h is equals to 0.02. Okay. Next, f of a the value of f of a. What is f of x? F of x is a 4 pi x square. Therefore, f of a is equals to f of 3 is equals to 4 pi 3 raised to 2. And 3 raised to 2 means what? 9. 9 into 4, that is a 36 pi. Next is f dash of a, means what? F dash of 3, that is a 8 pi 3, and that's equals to 24 pi. Therefore, the formula for the approximation, f of a plus h is approximately equal to f of a plus h into f dash of a. Now we'll substitute the values. It's very simple. Therefore, f of 3 plus 0.02, that's equals to 36 pi plus 0.02 into 24 pi, and after substituting we have here that is a 36 pi plus 0.48 pi, and their addition is 36.48 pi centimeter square, and this is the surface area of the sphere. Okay, and hence the option B is the correct one. Okay, now we'll take the next example. For f of x is equals to 2 plus in bracket x minus 1 bracket square, where x belongs to the closed interval 0 to 2. The value of c by applying the Rolls theorem is, what will the value of the c? That is, first option is a 3 by 2, second is 2 by 3, c is 3 by 4, and d is 1. You want to find out the value of the c. It's very simple. Now first of all, what is meant by the Rolls theorem? See this here. If a function f is defined on closed interval ab is, what type of that function must be? It must be continuous on closed interval ab, differentiable in open interval ab, and f of a is equals to f of b. Then there exists at least one real number c between a and b, such that c lies between a and b here, such that f dash of c is equals to 0. We'll apply here. We want to find out the value of the c. Now what is our function? Our function is f of x is equals to 2 plus x minus 1 bracket square. It's a derivative. F dash of x is equals to 2 in bracket x minus 1, and that's equals to 0. It implies that is a x is equals to 1, and it belongs to the closed interval 0 to 2, and hence the option D, that is a 1, is a correct one. Okay, Rutuja. Next question. If the function f of x is equals to ax cube plus bx square plus 11x minus 6 satisfies the conditions of Rolls theorem in closed interval 1 to 3, and f dash of 2 plus 1 upon root 3, that's equals to 0, then what are the values of a and b? Okay, now let us try here. We have given it satisfies now the condition. F dash of this c is equals to 0, then what will the values of a and b? Okay, good evening Dhanashri. Now here the function f of x is equals to ax cube plus bx square plus 11x minus c. Then by Rolls theorem, that is f of 3 is equals to f of 1. Therefore here in this equation, that is f of x is equals to ax cube plus bx square plus 11x minus 6. Here x is replaced by first of all 3. Therefore as x is replaced by 3, 3 raised to 3 means what? 27a plus 3 raised to 2 means what? 9b plus 11 into 3. Okay, 33 minus 6, and to the right hand side. On the right hand side, take the same function and replace here x by 1. Therefore here you will get a as 1 cube is 1, as 1 square is 1, 11 into 1 is again 11. Therefore here is a plus b plus 11 minus 6, and after simplification, this is a 27a minus a, you will get 26a, 9b minus b, you will get 8b, and that's equals to minus 22. Now divide this equation by 2, and hence you will get 13a plus 4b is equals to minus 11. And by trial and error method, by using the elimination method, we'll solve this. This condition is satisfied only 1 and minus 6, and hence the option A is correct one. Okay. Now we'll solve this next question. See this here. For f of x is equals to x in bracket x minus 1 into x minus 2 and the closed interval 0 to 1 upon 2. The values of c in the Lagrange's mean value theorem is. What will the values of the c? That is, we have given the first option, that is a 1 minus root of 15 upon 6. B is 1 plus root of 15. C is 1 minus root of 21 upon 6. And D is 1 plus root of 21. Now let us try. If a function defined on closed interval AB is continuous in closed interval AB, differentiable in open interval AB, then there exists at least one real number C in between A and B such that f dash of C is equals to f of B minus f of A upon B minus A. Now we'll find out the values. Now what is f of 1 upon 2? F of 1 upon 2, that is a replace in this polynomial, that is a x by 1 upon 2. Then here you will get f of 1 upon 2 is equals to 1 upon 2 in bracket 1 upon 2 minus 1 into in bracket 1 upon 2 minus 2, and after simplification you will get 3 by 8. And what about the f of 0? It's clear that f of 0 is equals to 0, and hence by the Lagrange's mean value theorem, that is LMFT, for some c belongs to this open interval 0 to 1 upon 2, f dash of c is equals to, good evening Dhanashri, f dash of c is equals to f of 1 upon 2 minus f of 0 upon 1 upon 2 minus 0, and after substitution we will get, that is a 3c square minus 6c plus 2, here f of 1 upon 2 minus f of 0 upon 1 upon 2. Substitute the value of 1 upon 2, which is 3 by 8, f of 0 is 0, and here is a 1 upon 2, 1 upon 2 minus 0, here is a 1 upon 2, and after simplification here you will get 3 upon 4. Okay, here is a 3 upon 4, 3 by 4, and 3c square minus 6c plus 2 is equals to 3 by 4, and here again we will simplify here. That's we will get here, that is a 12c square minus 24c plus 8 is equals to 3. And to find out the roots of this equation, we will apply the formula. That is, what is the formula? That is ax square plus bx plus c is equals to 0. Then x is equals to minus b plus or minus in under root of b square minus 4ac upon 2a. Okay, therefore c is equals to plus or minus b here, that will become 24 plus or minus in under root of b square, means what? 24 square is a 576 minus 4 into 12 into 5 upon 24, and after simplification you will get 24 plus or minus in root of 336 upon 24, and hence you will get 1 plus or minus 4 into root of 21 upon 24, and hence here you will get the value. That is the option C is the correct one. That is only 1 minus root of 21 upon 6 belongs to this interval. Okay, now the next question. If f of x is differentiable in closed interval 2 to 5, where f of t is 1 upon 5, we have given its value. F of 5 is again 1 upon 2. There exists a number c which lies between 2 to 5. Then for what value of f dash of c? The first option is 1 upon 2, b is 1 upon 5, c is 1 upon 10 and d is 1 upon 15. Now again, here is again Lagrange's mean value theorem. By LMVT, f dash of c is equals to f of 5 minus f of 2 upon 5 minus 2. Substitute the value of f of 5, that's we have given, it is 1 upon 2. F of 2 is 1 by 5. 5 minus 2, that is 3. And after simplification, here you will get 1 upon 10. Therefore, for sum C, which lies between 2 to 5, that is option C is a correct one. Now the next question. This is the question. Again, this is the important question, that is to find out the values for the given function increases. We want to find out the interval. The function f of x is equals to 2x cube minus 3x square minus 12x plus 12 increases in which interval? The first A is minus infinity to minus 1 union open interval 2 to infinity, B open interval minus 1 to open interval 2, C is open interval 2 to infinity and D is open interval minus infinity to minus 1 intersection open interval 2 to infinity. Now we want to find out, as the given function is increases, its value must be, its first derivative must be greater than 0. F of x is equals to 2x cube minus 3x square minus 12x plus 12. Therefore, f dash of x is equals to 6x square minus 6x minus 12. F increases if f dash of x is greater than 0. Therefore, 6x square minus 6x minus 12 is greater than 0. And here after simplification, that is divide the whole inequality by 6. Then you will get x square minus 6 is greater than 2. Now make this as a perfect square. Add the second term. Then how to find out the second term? This is the middle term. Divide by 2. Then you will get, after dividing, the coefficient of x is 1. Then 1 upon 2. The second term is 1 upon 2. Add 1 by 4 on the both sides. Then we get x square minus x plus 1 by 4 will become the perfect square. That is, it's a perfect square of x minus 1 upon 2 bracket square. What about on the right hand side? That is a 2 plus 1 by 4. That is, add on both sides by 1 by 4 to make the left hand side as a perfect square. Therefore, 2 plus 1 by 4 is equals to 9 by 4. Therefore, x minus 1 upon 2 is bracket square is greater than 9 by 4. Now here we will take the square root on both sides. That is x minus 1 upon 2. 1 is first is it's a greater than 3 by 2 or plus or minus. The square root of 9 by 4 is a plus or minus 3 by 2. If we take plus sign, then x minus 1 upon 2 is a greater than 3 by 2. Or if we take the negative sign, then you will get x minus 1 upon 2 is less than minus 3 by 2. And if we consider the number line here, the for x is greater than, if we simplify this, x is greater than 2, then you will have this type of the range. And suppose that if x is less than minus 1, then this will be the here x, and if is greater than 2, then this will be the range. And therefore, and hence f increases from minus infinity to this minus 1. Okay, and union with 2 to infinity, and hence the option A is a correct one. Now we'll take the next question. The values of x for which f of x is equals to 4x square plus 1 upon x is decreasing are, what type of that values are? The first is x is less than minus 1 upon 2 and x is greater than 1 upon 2. Next is x lies between minus 1 upon 2 and plus 1 upon 2. C is x is less than minus 1 upon 2 or x is greater than 1 upon 2. Okay, these are the values. Now we'll solve here. See this here, the f of x is equals to 4x square plus 1 upon x. After simplification, that is 4x square upon x, then you will get 4x plus 1 upon x. This is a 1 upon x. What's its derivative? F dash of x is equals to derivative of 4x is 4. Derivative of 1 upon x is minus 1 upon x square. And after simplification, here you will get 4x square minus 1 upon x square. Now from the numerator, take 4 as common. Then you will get x square minus 1 by 4 upon x square. Now what are the factors of x square minus 1 by 4? The factors of x square minus 1 by 4 are 4 in bracket x minus 1 upon 2 into x plus 1 upon 2. Now for the f dash of x is less than 0. If it's less than 0 means it is a negative. When this will happen, that is x lies between minus 1 upon 2 and plus 1 upon 2. Therefore, f of x is decreasing when x lies between minus 1 upon 2 plus 1 upon 2. Now, how this comes? See this here. That is, f dash of x is negative. Means what? The product of these two, that is x minus 1 upon 2 and x plus 1 upon 2 must be negative. Means what? X in first condition, x minus 1 upon 2 is negative and x plus 1 upon 2 is a positive. And after simplifying this, you will get here x is less than 1 upon 2, and after simplification of this, x is greater than minus 1 upon 2. X is less than 1 upon 2 and x is greater than minus 1 upon 2. It means that x lies between minus 1 upon 2 and plus 1 upon 2. Now the second condition. In first condition we take this as negative and this as positive. In second condition it will be the reverse. What is that? X minus 1 upon 2 is positive and x plus 1 upon 2 is a negative. But this is not possible. How it is not possible? Here x is greater than 1 upon 2 and again he say that x is less than minus 1 upon 2. This is not possible and hence x lies between minus 1 upon 2 and plus 1 upon 2 is a possible. Okay. Now we'll take the next question. See this here. F of x is equals to 2x for all real x is, what type of the function is? Increasing, decreasing, neither decreasing nor increasing, and D is an even function. We'll find out the answer. See, this is the function. It's very simple question. F of x is equals to 2x. The function will increase if x is positive and will decrease if x is negative, and hence the option C is a correct one. That is a neither decreasing nor increasing. Okay. Now the next question. Question number 60. F of x is equals to x minus log of 1 plus x for x is greater than minus 1. Is increasing in which interval? First is 0 to infinity, b is minus 1 to 0, c is minus infinity to 0, and d is 1 to infinity. We want to find out the condition for the increasing. See this function. F of x is equals to x minus log of 1 plus x. Okay. Now find out its derivative. F dash of x. Derivative of x is 1 and derivative of log of 1 plus x is 1 upon 1 plus x. And after simplifying this, then you multiply this 1 plus x to this one, then you will get 1 plus x minus 1 upon 1 plus x, and their simplification, here you will get x upon 1 plus x. This will be positive if x is greater than 0. Therefore, f is increasing in the open interval 0 to infinity. Okay, and hence the optional A is correct one. Okay, so this is the next question. F of x is equals to sine of 2x where x belongs to closed interval 0 to pi is first increasing in 0 to pi by 2 and decreasing in pi by 2 to pi, decreasing in 0 to pi by 2 and increasing in pi by 2 to pi, increasing in 0 to pi by 4 and decreasing in pi by 4 to pi by 2, decreasing in 0 to pi by 4 and increasing in pi by 4 to pi by 2. Now let us try here. See the function. F of x is equals to, we will get the answer here. F of x is equals to sine of 2x. Then what's its derivative? F dash of x is equals to derivative of sine of 2x is a cos of 2x. Again it is a composite function. Derivative of 2x is 2 here. Therefore f dash of x is equals to 2 times cos 2x. Now for the increasing, f dash of x must be greater than 0. Okay. For f dash of x must be positive, the values of 2x must lies between 0 to pi by 2, that it must be in first quadrant. Now divide on both sides by this inequality by 2, then what you will get? 0 is less than x is less than pi by 4. And if f dash of x is less than 0, then what will happen? This is the cos function, that is the range of this, the value of x must be from pi by 2 to 3 pi by 2. Therefore as pi by 2 to pi, okay, from this pi by 2 to pi, and here is a, we'll write here, therefore we'll write here, that is pi by 2 to x, that is the 2x lies between pi by 2 to pi, and that's why here divide again on both sides this inequality by 2, then you will get pi by 4 is x is lies between pi by 4 to pi by 2, and hence f of x is increasing in interval 0 to pi by 4 and decreasing in the interval pi by 4 to pi by 2, and hence the option C is a correct one. Okay. Now again we'll take the one more problem. The function f of x is equals to x cube minus 6x square plus 9x minus 2 has minimum at x is equals to 1, 2 or minus 6 or t is a 6. See this function. F of x is equals to 2x cube minus 9x square plus 12x plus 5. Then what is its first derivative, which is 6x square minus 18x plus 12. Second derivative is a 12x minus 18. For maxima and the minima, we'll find out its value. F dash of x is equals to 0 to find out the value of x. Therefore 6x square minus 18x plus 12 is equals to 0. Take 6 as common, then you will get, or simplify this, you will get divide on both sides by 6. X square minus 3x plus 2 is equals to 0. Therefore in first bracket x minus 1 into x second bracket x minus 2, and after simplification, or the factors are x is equals to 1 or x is equals to 2. Since f double dash of 2, that is a 24 minus 18, which is the positive greater than 0. What is the second derivative? The second derivative is a 2x minus 18. Substitute the value. F of f at x is equals to 2. We'll have the 6, which is a positive. Therefore f as minimum at x is equals to 2. And in this way we have completed this session.